For this example, we just want to show how the formula for the critical angle is derived from Snell's law. So we're just going to start with Snell's law. N1 sine of theta 1 is equal to N2 sine of theta 2. The critical angle, which we're going to define as theta c, is the incident angle. So that's going to take place of the theta 1. So theta c is the critical angle. It's the incident angle that would result in the refracted angle being 90 degrees. So we want the theta 2 to be 90. And since we know that the sine of 90 degrees is equal to 1, that basically tells us we can get rid of this whole term right here, because n2 times 1 is just equal to n2. So we now have just n1 sine theta c is equal to n2, and then just divide both sides of the equation by n1, and you're left with the sine of the critical angle is equal to n2 divided by n1. Notice that the way the answer works out, whenever you take the sign of any number, the answer is always a number less than 1. So the only way this can be a number less than 1 is if n1 is greater than n2, which means it has to go from a higher index of refraction, the n1, to a lower index of refraction, the n2, in order to have a critical angle. If you went from a lower index to a higher index, this fraction right here would be greater than 1, and you can't take the sine of an angle to get an answer greater than 1, so there's no way to get a critical angle when you're going from a low index to a high index. You have to go from a high index to a low index of refraction.